Hi. So today I'm going to discuss cloud architectures. This presentation is based on four main topics. First, I will discuss the business benefit of cloud architecture. Second, I will explain some examples of cloud architecture. Third, I will discuss service load balancing architecture. Finally, I will explain redundant storage architecture. Cloud architecture means the way different cloud technologies, services, servers, storage system and network are organized to work together. Today, many organizations use cloud computing because it allows them to access computing resources through the internet. They do not always need to purchase and manage many physical servers by themselves. Cloud architectures help organizations build systems that are flexible, reliable, and able to manage different levels of customer demand. Let us begin by understanding why cloud architectures are important to business. In slide 2, cloud architectures provide a structured way to use cloud services. The services can include software as a service, platform as a service, infrastructure as a service. They are also known as SaaS, PaaS, and IaaS. In a traditional IT environment, a business may need to purchase physical servers, install them, and maintain them. This can take a lot of time and money. Cloud architecture provides different approach. Application can run in the cloud while the cloud provider manages physical infrastructure. The business can access cloud services through the internet using simple application interface also known as APIs. Another important feature is that cloud services can scale according to demand. For example, when the numbers of customers increases, the system can provide more resources. When customer demand decreases, unnecessary resources can be removed. Therefore, business can use resources only when they are needed. They are useful for seasonal business, temporary projects, and application with change in workloads. In slide 3, business benefits and cloud architectures. These are several important business benefits of cloud architectures. The first benefit is cost efficiency. The business does not need to purchase a large number of servers for the highest possible workload. Instead, it can use instead Instead, it can use cloud resources when required. In many cloud systems, the business pays according to its actual usage. This also prevents expensive servers from remaining unused. The second benefit is scalability. Cloud system can increase or decrease computer resources when workloads change. This can happen without manually installing a new physical machine every time. The third benefit is faster service delivery. Developers can obtain servers, storage and other services more quickly. Therefore, they can develop, test and release applications faster. Another benefit is reliability. Cloud architectures can use application, failover systems and redundant resources. If one resource fails, another resources can continue providing the service. Cloud architecture is also improved resources utilization. CPU, memory, and storage can be allocated according to the actual requirements. As a result, business can reduce waste, control costs, and provide a more reliable service to their customers. Slide 4, example of cloud architectures. The lectures introduce several examples of fundamental cloud architectures. The first example is workload distribution architecture. It uses a load balancer to distribute work between identical IT resources. The second example is resources pooling architecture. In this architecture, similar resources are grouped into pools. These may include physical servers, virtual servers, storage, CPU, memory, and network resources. Another example of dynamic scalability architecture. It automatically changes the amount of valuable resources based on workload condition. Elastic resource capacity architecture dynamically allocates or removes CPU and memory from virtual servers. Service load balancing architecture distributes consumer requests between different copies of the same cloud service. Cloud bursting architecture allows an organization to use cloud resources when its on-premises system reaches its capacity limit. Elastic disk provisioning architecture provides storage according to actual usage. Finally, redundant storage architecture creates a duplicate storage device to protect data and support failover. Each architecture solves a different problem with a cloud environment. In slide 5, Okay, let's look more closely at some of these architecture examples. In resources pooling architecture, identical or similar ID resources are grouped together. For example, CPU resources can be placed in a CPU pool, memory can be placed in a memory pool, and storage devices can be placed in a storage pool. When an application needs resources, the required amount can be allocated from these pools. Dynamic scalability architecture uses primary conditions of threshold and automated scaling listener monitors and workload. When demand becomes high, the system can add more resources. When demand fails, the system can remove unnecessary resources. Cloud bursting architecture connects an organization local system with a cloud environment. Normally, the organization uses its own premises resources. However, when those resources reach their capacity, additional work can be moved or redirected to cloud resources. When the extra cloud resources are no longer required, they can be released. These examples show how cloud systems move away from fixed infrastructure and became more flexible, automatic, and responsive. In slide 6, I will discuss service load balancing architecture. Service load balancing architecture is a specialized from workload distribution architecture. Its main purpose is to scale cloud service implementation and distribute consumer requests between different service intents. In this architecture, several copies of the same cloud service are created. These copies may run on different virtual servers. A load balancer is placed between a consumer and cloud service. When consumers send requests, the load balancer intercepts those requests. In then forward each request and available service instance. This means that one virtual server does not need to process every request. Instead, the work is shared between multiple servers. This is known horizontal scaling because more identical service instances are added. The main purpose is to avoid overloading, and cloud service instance can also provide a more stable service when may. So, then slide 7. How service load balancing works. Service load balancing can be explained using four main steps. In the first step, cloud consumers send requests to cloud service. These consumers may be individual users, mobile application or other computer systems. In the second step, the load balancer receives the request. The load balancer uses the runtime logic to select a suitable service instance. For example, it may select the server that currently has the smallest workload. In the third step, requests are distributed between multiple virtual servers. Each virtual server contains a copy of the same cloud service because the requests are shared. Workload processing is horizontally scaled. In the fourth step, monitoring and supporting mechanism help manage process. A cloud usage monitor can track service usage and resource consumption. A resource cluster can allow several active resources to work together. Resources replication can create additional copies of the cloud service when more capacity is needed. The final result is improved performance, better resource utilization, and smoother scaling when demand increases. It can also improve availability because another service instance may continue processing requests if one instance becomes unavailable. Slide 8. The next topic is redundant storage architecture. The purpose of this architecture is to keep data available when storage device fail. In this architecture, there is primary cloud storage device, a secondary cloud storage device. The secondary device is duplicate of the primary device. Data from the primary storage is copied and synthesized in secondary storage. A storage service gateway manages access to the storage system. Under normal condition, cloud consumer requests are sent to primary storage device. However, if the primary storage device becomes unavailable, the storage service gateway redirects the request to secondary storage device. In slide 9, redundant storage architecture works through replication and failover. The first stage is replication. Storage replication system regularly copies and synchronize data from the primary storage device to the secondary storage device. The second stage is failure detection. The third stage is failover. So in conclusion, cloud architectures provide practical methods for building flexible, scalable, reliable cloud systems. They help organizations solve many problems found in traditional IT environments. Cloud architectures can reduce the difficulty of purchasing and managing physical machines. They also allow organizations to use restructure according to the actual demand. Service load balancing architecture distribute requests between multiple copies of the same cloud service. This prevents the one service instance from becoming overloaded and support horizontally scale. Thank you for listening to my presentation.